Alright, this is lesson 28, deriving the quadratic formula. So in Algebra 1, you learned about this formula called the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Raise your hand if you've seen this formula before. You all should have already know this one, okay? So we use a quadratic formula when we want to solve quadratic equations. Let me move it down over here, okay? But someone made this up, and it wasn't that hard, but it wasn't more advanced math, and this is one of your standards to learn is how did we figure this out, okay? So you know that we can use it. We've looked at quadratic equations. How do we solve them? We solve them. The first way I taught you was factoring through x box. And we did the zero product property, and then we solved x is equal to 3 or 5, right? But the second way I taught you was take a square root of both sides. So you would isolate the x squared term, and then you're going to take a square root of both sides, and then you're going to get two answers. The third way I taught you was complete the square, which was that big, long process. And the fourth way I taught you was the graphing, where you look at where the graph crosses the x-axis. Those are called your roots or zeros, okay? So, the last word you could use is the quadratic formula, and the quadratic formula actually came from complete the square. So, complete the square is the same format every time. You always move c to one side, you move all your constants over, you take half of the middle term, you square it, add that to both sides, and then you always repeat yourself, right? It's pretty repetitive when we do complete the square every time, right? Would you agree with me? You're just using different numbers. Would you agree? Yeah? Okay, so each number is a variable. So someone thought, okay, how do I get from an equation down to here? Okay, because I don't really want to complete the square every time. I could use a formula. So someone showed the work on how to do this, and we're going to actually do that today and work it out. So that's the purpose of today's lesson, is to show how do we get from the original equation all the way to the quadratic formula and all the steps that are in the middle. We're going to do that. That's the goal. Okay, and you have to memorize the steps. You have to memorize how to do it. So it's going to look kind of crazy. It's going to look really hard, but we're going to do a lot of repetition today, and you'll get it, okay? And you have 2 weeks. Then this will be a question on a test, okay? For sure. Here are the steps for today. I'll give you a moment to write that down. You'll notice these steps are all like complete the square steps, right? So because we're just repeating complete the square over again with variables instead of numbers, okay? Because there's always going to be different numbers for A, B, and C. So the quadratic formula just cuts all of that into one easy step, okay? So, but the whole goal today, again, is to figure out why, or where did the quadratic formula come from? How do we derive that, okay? So, here we go. So here's the original quadratic equation. Our three variables are A, B, and C. So all your problems will always have a number A, B, and C that we've seen, okay? So usually when we want to solve something, we would do complete the square. So the way you start off with this is you subtract the constants and move them to the opposite side, which is C. We're going to subtract C first. So you're left with a new equation. It's ax squared plus bx is equal to negative c. Okay? That's the first step we always did, right? Then we looked at this middle term, which is b, right? Looked at b, and we would take this b to the side. We would move it to another place, and we think about it on the side. We'd say, okay, b, half of b is really like saying, I'm sorry, even before that, we're not even looking at b. I'm sorry. Before that, looking at the number in front of the x squared, okay? What's the number in front of the x squared? Is it a 1? No, it's a. So we want it to be a 1, so we have to divide everything by a, both the left and right side. So we're going to get x squared plus b over a x is equal to negative c divided by a. Okay? now we have a 1 in front of the x squared. Okay? Since we have a 1 in front of the x squared, now we can look at our middle term, which is b over a. And we're going to take this to the side, the b over a, down here. We'll just look at it. So b over a, I know that I can make, or divide b over a in 2 by just putting, multiplying the denominator by 2, so it's going to be b over 2a. And b over 2a squared is going to be b squared over 2a squared, which is just 4a squared, right? Because 2 squared is 4, a squared is just a squared. We're going to add this value back up here on the top. So we're going to add it right here, plus, use a different color so you can see it, plus b squared over 4ac, and we're adding this to both sides. Okay. When we do that now, the left side's a perfect square trinomial, so we got x plus b over 2a squared is equal to b squared over 4ac minus c over a. Okay, so that was that step. Now the left side's already a perfect square. I could take a square root, but I want to clean up this right side before I move on, okay? Right now these two denominators are not the same, so I want them to be the same. A common denominator for both of these is going to be, why is this 4ac? It's supposed to be 4a squared, I'm sorry, not ac. I had a squared, this section here. Sorry about that. 4a squared. Okay, so we have 4a squared and a here. There wasn't supposed to be a c there. Common denominator here. We have 4a squared and a here. So this is like saying 4 times a. Right here we just have a. Right? So what do I have to multiply this side to get 4a squared? 4a, okay? Multiplying the left and the right side by 4, or top and bottom by 4a, because I know I'm going to get a common denominator of 4a squared. So we got 4a squared, or b squared over 4a squared, minus 4 times, or c times 4 times a is going to be 4ac, all over 4a squared. Okay, and when I combine these two in the common denominator now, I'm going to get b squared minus 4ac all over 4a squared. Okay, are you all seeing a common part of the quadratic formula now? Something familiar? Okay. And the left side, let's just leave the same. X plus b over 2a squared. Okay. Now that the right side's all cleaned up, I'm going to take a square root of both sides. When I do that, okay, left side's going to be x plus b over 2a, which is equal to the positive and negative square root of b squared minus 4ac all over square root of 4a squared. Okay. I want to isolate the x on the bottom, so I need to subtract the b over 2a. So I'm going to move this all up here now. So we got x is equal to, I'm subtracting b over 2a, plus or minus square root of b squared minus 4ac all over, okay, what's the square root of 4, everyone?
2.
Square root of a squared?
A.
Good, so the denominator should be
2a.
2a, good.
All over 2.
Now look over here, are my two denominators the same here?
Yeah.
Yeah, so I'm going to write it all as one common denominator, so it's going to be x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I can't really simplify anymore, but isn't that our quadratic formula?
Yeah.
And that's it, okay? So this is a conceptual problem, and I know I said that's it, but that's, it's hard. But you have to know how to get from the original problem to here, okay? That's the goal. It's a concept. Okay? Does that make sense, everyone?
Yeah.
Okay? So, what I need you to do before we talk is I need you to write this down on your papers, and then we're going to spend the majority of our time talking. So, ready, go.